Jai Hind students, welcome to my YouTube channel. Students, problems are essential for human growth. In crisis, in turmoil, in trying circumstances, there lies an opportunity to show your real character. So never be afraid of any sort of trying circumstances. Try to come out with flying colors. Face the adversity, right? So students, with that, let's begin this session. In the previous lectures, we have discussed the different cases of projectile motion. We have discussed 6 or 7 different cases, starting from the horizontal projection to the angular projection. So theoretically, we are done with the projectile motion, right? Now, it's turn for numericals. Without numericals, this topic won't get completed. So, I've come with these 6 set of questions, right? So, let's start with the first one. So, students, first question is, two bodies are thrown with the same initial velocity. So, initial velocity is constant at angles theta and 90 minus theta to the horizontal. Determine the ratio of the maximum heights reached by the bodies. So, students, here the angular projection in the first case is given to be theta, and in the second case it is given to be 90 minus theta. And it is the case of angular projection where the body is projected making an angle theta or 90 minus theta with the horizontal. So, this is the case basically. Velocity is u and this is theta, right? So here the ratio of the maximum heights. In the first case, suppose it is h1. So what is the formula over here? It is u square sine square theta divided by 2g. In numericals, obviously we are supposed to make use of the formulas directly. We all have derived these expressions, isn't it? So this is the first case. Now what about the second scenario? It is projected with the same velocity, but now the angle of projection is 90 minus theta with the horizontal. So suppose in this case the maximum height is h2. So over here h2 it will be equal to u square sine square, in place of theta now it is 90 minus theta divided by 2g. So that will be equal to u square sine 90 minus theta is cos theta. So it will be equal to cos square theta divided by 2g. You can put this as equation 2. We are supposed to determine the ratio of the maximum heights reached in the two cases. So dividing 1 and 2, what do you get? h1 by h2. U square by 2g, u square by 2g being common, it will get cancelled. So we will be left with sine square theta divided by cos square theta. And that obviously is tan square theta. Simple, students. Just you have to directly make use of this formula, right? So we are over with question number 1. The ratio of the maximum heights reached by the two bodies is tan square theta. So that is what we obtained over here. Okay, let's proceed with the second question, students. Let me read the question for you. Second question is, a body is projected such that its kinetic energy at the top is 3 by 4th of its initial kinetic energy. What is the initial angle of projection of the projectile with the horizontal? Okay, it's an interesting question. This is the scenario. Theta is the angle of projection with respect to the horizontal, right? So, body will follow a parabolic path like this. This is the highest point. And here, the initial kinetic energy is E, and over here velocity is U. So, initial kinetic energy, that is equal to E, and it is equal to half mu square, where m may be considered to be the mass of the projectile under consideration, right? Now students, you must remember, at the highest point, the vertical component of velocity becomes 0. So at the highest point, only the horizontal component of velocity is there, because horizontal component of velocity at any instant during the motion of the projectile will remain constant. So what is the horizontal component of velocity? It is u cos theta. So here also it will be u cos theta. It will remain constant. The vertical component at the highest point is 0. So here the net velocity of the projectile at the highest point is u cos theta, right? So net velocity at the highest point is u cos theta. It's not zero. The vertical component of velocity of the projectile at the highest point is zero. Net velocity is equal to the horizontal component of velocity, which is u cos theta in this case. Therefore, students, kinetic energy at the highest point, it would be equal to, kinetic energy formula is half mv square. So half m u cos theta, its whole square. So what do you get? Half m u square cos square theta. Half mu square is the initial kinetic energy, so we get E cos square theta. Right? Now come back to the question. A body is projected such that its kinetic energy at the top. So kinetic energy as per the question at the highest point is equal to 3/4 its initial kinetic energy. Initial kinetic energy is E. So let's substitute the value over here. Kinetic energy at the highest point is E cos square theta, and it is equal to 3/4 E. So E get cancelled. So cos theta, it would be equal to root 3/2. Root 3/2, students. So it is equal to cos 30 degree, which further implies that theta is equal to 30 degree. So students, the angle of projection must be 30 degree. That is, the body must be projected at an angle of 30 degree with the horizontal, right? So we are over with question number 2 as well, right? So let's concentrate on next question, question number 3. It is the case of horizontal projection. A projectile is thrown horizontally from the top of a tower and strikes the ground after 3 seconds at an angle of 45 degree with the horizontal. Find the height of the tower and the speed with which the body was projected. So students, third question is somewhat like this. This is the building. Its height is to be determined. Suppose its height is h. This is to be determined. And this is the ground. So this is the projectile and it is projected horizontally, right? Obviously it will follow a path like this. And what else is given? Strikes the ground after 3 seconds. That's the time of flight. So if it is t equals to 0, so at this point it will be t equals to 3 seconds, right? And it strikes the ground at an angle of 45 degree with the horizontal. So here, this is the resultant velocity. And it is making an angle of 45 degree with the horizontal. Clear, students? Now, as I mentioned it time and again, projectile consists of 2 motions, independent motions, horizontal and vertical. Horizontal motion, it covers with uniform speed. That is, the horizontal component of velocity will remain constant. So this will be u only. So horizontal component of velocity, that remains same. And vertical motion, it is under the influence of gravity. So when the projectile comes downward, then the magnitude of its vertical component of velocity keeps increasing at the constant rate. Here, the initial vertical component of velocity is 0. But as it is coming downward, it will keep on increasing. And at the instant when it strikes the ground, it will be maximum Vy. Clear? And obviously, the vertical and the horizontal component of velocity, they are mutually perpendicular to each other. These are the 2 rectangular components, right? Okay, let's consider the first one. We are supposed to find out the height and time is given. So, we'll consider motion along vertical and we'll make use of second equation of motion, right? So, let's consider second equation of motion. S equals to ut plus half at square. Let's consider second equation of motion along the vertical direction. In total time 3 seconds, the body has covered vertical displacement of h. Uy initial velocity at this point is 0 plus half ay, it is coming downward, so ay is equal to plus g, that is plus 9.8 meter per second square. So it is 9.8. Time is given to be 3 seconds. That's the time of flight. So 3 square, right? So what you get is h would be equal to 4.9 multiplied by 9. So that will give us 44.1 meters. So this is the height of the tower, students. Simple, no need to remember any formula. You need to understand how we have derived these formulas during those theoretical concepts, right? So you need to understand the concepts. So that's the height, 44.1 meter. Now we are supposed to find out the velocity with which the body was projected. U is to be found. And students again make use of the information given. The body strikes at an angle of 45 degree with the horizontal. This angle is given 45 degree. This angle is 90 degree. Now remember always the resultant. Whenever the resultant bisects the angle between the two given vectors, then those two given vectors must be of equal magnitude. So here Vx must be equal to Vy. No doubt regarding this. Again, I must remind you of a very basic fact. The angle between Vx and Vy is 90 degree. The resultant is making an angle of 45 degree with either of these two vectors, isn't it? It means that resultant is bisecting the angle between Vx and Vy. It clearly suggests that Vx must be equal to Vy. Clear? So now let's consider first equation of motion. V equals to u plus at along vertical. Now Vy. Let's find out Vy. Uy is 0. Ay is plus g, that is 9.8. Time is total time of flight, that is 3 seconds. So Vy, it is equal to 29.4 meter per second. And since the resultant bisects the angle between these two, therefore the magnitude of Vx must be equal to magnitude of Vy. Each should be equal to u, and which implies that the initial velocity of the projection must be 29.4 meter per second. So this is the second answer of the second part. So the velocity of projection of the projectile would be 29.4 meter per second. So students, I hope you are totally convinced, right? So here make use of the vector properties. Right? Angle between Vx and Vy is 90. The result makes an angle of 45 degree. It means that the magnitude of this horizontal and vertical component must be equal. And that is the fact which I have made use of in solving this question. Okay students, we are over with question number 3 as well. Right? Let's proceed to the next question then. Question number 4. It's an interesting one. A cricketer can throw a ball to a maximum horizontal distance of 100 meter, right? Maximum. So it is the Rmax given. So maximum range, it is given to be 100 meter. This is given. How much high above the ground can the cricketer throw the same ball? Now look, this is the scenario basically. Range will be maximum only when he projects it at an angle of 45 degree. This is a known fact. Then only range would be maximum. And maximum range is u square by g. So, u square by g is equal to 100. It's given. The formula for the maximum range is u square by g. And range is maximum only when the angle of projection is 45 degree. This we are aware, right? We have done it in the theoretical portion. Now students, look. We are supposed to find out how much high above the ground can the same cricketer throw the ball, right? Same ball. So if he intends to throw the ball in the vertically upward direction, right? So what is the maximum height attained by it? Suppose it reaches up to this height. It reaches up to height h. So on reaching the highest point, its final velocity will become 0. So if you consider the motion from O to A and make use of the third equation of motion, what you get is 2as is equal to v square minus u square. Now let's consider the motion along vertical direction. So y component. Okay, body is moving in the upward direction, so AY is minus G. SY, it is H. VY at the highest point, the velocity of the body will obviously become 0, minus UY, the initial velocity, that's considered to be U, same velocity of projection. Minus minus get cancelled, so H, it will be equal to U square divided by 2G, which is half U square by G. And from equation 1, U square by G is having value of 100. So what do you get? Half U square by G, it is 100. So that will give us 50 meters. So if the cricketer tends to throw the ball in the vertically upward direction, then the maximum height attained by the ball would be 50 meters. So this is the solution of question number 4. So we are done with question number 4 as well, right? Now let's proceed to question number 5. Students, let me read the question for you. It's again an interesting question, simple and interesting one. The range of a projectile when launched at 15 degrees with horizontal is 1.5 km. Let's make use of this fact, right? What's the formula for the range? It is U square sine 2 theta by G. This is the formula for the range when the projectile is projected with velocity U, making angle theta with the horizontal. So, for theta is equal to 15 degree, R is given to be 1.5 kilometer, right? So, 1.5 kilometer, let me write it in kilometer only. In case we need to convert it to meter, then it will be multiplied by 10 raised to the power 3. 1 kilometer is 1000 meters. So what do you get is U square sine 15 into 2, that will give us 30 degree divided by G. Clear? So that will give us 1.5 into 10 raised to the 3 is equal to U square by sine 30 is half, which implies that U square by G, it would be equal to 3 into 10 raised to the 3 meters or 3 kilometers, right? Here I am considering the SI thing. So distance is considered in meters. So put this as equation 1. Now let's consider the second part. What is the range of the projectile when launched at an angle of 45 degrees to the horizontal? Now, this was the first part. Second, for theta is equal to 45 degrees. Range, this is to be found. So over here, what will be the formula? U square sine 2 theta is 45 degree divided by G. So what do you get? U square by G, and it is sine 90 degree. Sine 90 is 1. So new range when the angular projection is 45 degree would be U square by G, which is 3 into 10 raised to the 3 meter or 3 kilometer. So students, when the angular projection is changed from 15 degree to 45 degree, then the range is increased from 1.5 kilometer to 3 kilometer, right? So 3 kilometers is the correct answer. Okay students, now the last question, sixth one. A projectile is thrown at an angle theta and another at an angle 90 minus theta from the same point with the horizontal, both with velocities of 98 meter per second. The velocity of projection both the cases is same. The second rises 110 meter higher than the first. Find their individual heights. So this is an important question. Okay, we'll consider the first case and then we'll consider the second case. In the first scenario, students, the angle of projection is theta and velocity is same. So over here, suppose height is h1, right? This is height h1. And in the second case, same velocity of projection, but the angle of projection is 90 minus theta. Here the height is h2, right? In both the cases, u is given to be 98 meter per second in both the cases. And it is given that the second rises 110 meter higher than the first one. So what is the given information? Given information is second one, H2. It rises 110 meter higher than the first one. So it is given to be H2 equals to H1 plus 110. This is the information which is given. Right? Okay. Over here, let's find out the value of H1. We are aware maximum height attained is given by u square sine square theta by 2g, right? So it is u square sine square theta divided by twice g. What about H2? H2 is, students, over here theta is to be replaced by 90 minus theta and sine 90 minus theta is cos theta. So here we will get u square sine square theta will be replaced by cos square theta, because here the angle of projection is 90 minus theta. So if you substitute over here 90 minus theta, we will get sine square 90 minus theta as cos square theta divided by 2g. So these are the expressions which we will be making use of, right? So H2 is equal to H1 plus 110. It is given. So we can substitute the value, or rather what we do is put this as equation number 1, or rather put this as equation number 1, this as equation number 2 and this as equation number 3. Right, students? Okay. What we do is, if we add second and third, because make use of your common sense, here it is cos square theta and here it is sin square theta. We have to make use of the identity that sin square theta plus cos square theta is equal to 1. So let's try to make use of it, right? So what we do is, let's add these two, second and third. So left hand side, what we get is H2 and over here H2. So students, let's substitute the value over here, second plus third. So what we get is H2 plus H2, that will give us 2H2. It is equal to u square cos square theta by 2g plus H1 plus 110. Simply add these two. Left hand side H2 plus H2, it will give us 2H2. Right hand side it will give us u square cos square theta by 2g plus H1 plus 110. Why we have done it? Because when we substitute this value of H1 over here, then sin square theta plus cos square theta, that can be put as 1, isn't it? So as to use that identity, we are making use of this thing. So what we get is 2H2, it will be equal to u square cos square theta divided by 2g plus substitute this value of H1, it would be u square sin square theta divided by 2g plus 110. So still further, what we get is u square by 2g is common in both the cases. So cos square theta plus sin square theta, it is equal to 1. So we will be left with only u square by 2g plus 110. Therefore, students, dividing throughout by 2, we should get the expression for H2. What we get is u square by 4g plus dividing throughout by 2. Here we get 55. Right? Now let's substitute this value of u and g over here and we should easily get the value of H2. Okay, let's solve it. Therefore, H2 is equal to u square. U is given to be 98. So 98 multiplied by 98 divided by 4g. 4 small g is 9.8 plus 55. Let's try to evaluate it. Okay, it will be 980 divided by 4 plus 55. So that will in turn give us 245 plus 55. So H2 is found to be 300 meters. So the second projectile, it has attained a maximum height of 300 meters. We are supposed to to calculate the individual heights, both h1 and h2. h2 is obtained to be 300 meters. Now from here, h1 is equal to h2, h1 is equal to h2 minus 110. So that will give us 300 minus 110. That will give us 190 meters. So students, the first projectile has attained a maximum height of 190 meters, while the second projectile has attained a height 110 meter more, that is 300 meters. That will be the maximum height attained by the second projectile. So after getting the result, you can cross-check whether it satisfies the given condition in the question or not, right? So I hope students you have understood the concept used in this particular numerical. So as I urge you time and again, practice more and more numericals. That's the only way you can gain confidence in solving numericals. There's no other shortcuts, right? So first, try to clear your theoretical concepts and then use those learned concepts and theoretical knowledge in solving such numericals. So do join me in my next lecture, then I'll come up with some new set of numericals based on motion in 2D, that is projectile motion. And till then, do take very good care of yourself. Thank you.
Thank you.